Good morning, ladies and gentlemen. Good morning, BSRT2 students. So, the last time we have discussed about the radioactivity, and we said that radioactivity is quite predictable. So, which means we can guess the time wherein it can undergo radioactivity. So, the time itself and the radioactivity is quite the discussion of our today's topic, which is all about half-life. So, do you have an idea when you heard the word half-life? Or what comes into your mind when you heard the word half-life? Anybody? Sige, hindi ko naman magagawa yan kasi this is a virtual classroom. So, based on our discussion on the base quantities, it has to be remembered that time is measured in terms of change. If nothing changes, then it is impossible to tell that time has passed. All devices that measure time measure change. Therefore, it is empirical to assume that radioactivity likewise varies with time. So, today we are going to discuss the relationship of radioactivity and time. The half-life of a radioisotope is the time required for a quantity of radioactivity to be reduced to one-half from its original activity. Theoretically, all radioactivity of a radioisotope never disappears. After each period of time equivalent to one-half of the activity present at the beginning of that time will remain. Therefore, although the quantity of radioisotope progressively decreases, so it never quite reaches zero. So, halimbawa, may kita radioactive substance nga aton tapad. So, it doesn't mean nga magwawara na la siya all of a sudden. So, may dangayan ginfa-follow niya nga time. So, after this span of time, magdi-decrease siya or magdi-decay siya into 50% from its original value. And that is what we call the half-life. So, sa sugad pa nga iba nga naguhugot-hugot, maupay pa ko na half-life, may time. Samantala hiya, waray. So again, half-life is the time required for a quantity of radioactivity to be reduced to half of its original value. It's a common misconception sa mga radtech students nga it question, halimbawa masugad, what is the half-life of the material? Itera gina-answer is the activity. Anira babaton, 100 millicurie, 100 becquerel. So, do not be confused. Millicurie, becquerel, these are SI unit for or units of radioactivity. So, pag sumuwad kita nga time, normally seconds, minutes, hours, days, months, etc. So, kailangan magpakiana nga ni dinhi what is the half-life of the materials. Your answer should be accompanied with a unit of time. So, ka nga 2 hours, 1 day, ganon, so, 1 month, ganon. So, again, diri siya parehas itibang tigda nala nawawara paron imo feeling sa iya or feelings niya imo nga tigda nala nawara. So there half-life, there is a span of time. Halimbawa 3 hours saka pa siya ma-decay into 50%. The next 3 hours pa 25%, the next 12.5%. So ganun it half-life. So and it never reaches quite zero. Mabuti pa siya, samantalang kayo, akala nyo may forever, pero natapos din pala lahat. Ito sa yung activity, hindi siya nawawala basta-basta. And hindi talaga siya nawawala. Radioactivity is never reaches quite zero. Okay, so we have 3 types of half-life. So first, we have physical half-life. So this pertains to the time required for half of any amount of radioactive material to undergo transformation. This period is distinct constant. Each radioactive substance and cannot be altered by temperature, by pressure, or chemical reaction. Kahit bisan ada pa itiyarid to hit mahagkot nga lugar, mapinit na lugar, bisan adto pa siya sa paso nga lugar, same it iya same it iya half-life. Same it iya period nga magdi-decay siya into 50% of its original value. Bisan may chemical reaction or pressure, so same lang gihapon. So in our topic, in this subject, particularly today, so we will be discussing the physical half-life. So, field of radiologic technology, we have quite mga examples nga igahatag that are particularly important to different branches of radiological sciences. So example, we have radium-226, which has a physical half-life of 1,600 years. And then this radium-226 was previously used in radiation therapy. Okay. Next, we have cobalt-60 with a physical half-life of 5.3 years. And then it is particularly useful in radiation therapy. Also, we have gold-198 with a half-life value of 2.7 days. This is useful in the field of nuclear medicine. Actually, nuclear medicine and radiation therapy can be one way or another particularly the same. Kasi ganun pa, nuclear medicine, ganun din, pwede siya sa treatment, pwede siya sa diagnosis. Yung radiation therapy kasi, specific siya, that is for the treatment, especially cancer. But in a way, if radiation or radioactive substance is used in the treatment of diseases, so pwede na natin siya matawag na radiation therapy. Next, we have iodine-131. It has a half-life value of 8.1 days, and this is used in nuclear medicine. And we have technetium-99. It has a half-life value of 6 hours, and it is used in nuclear medicine. So, yun. These are examples of radioisotopes that are useful in radiologic technology with their respective half-life. By the way, class, the symbol for half-life is T, 1/2. Capital letter T or small letter t, that is to designate time, tapos may dash siya 1/2. Okay, so that's the first type of half-life. The second type of half-life is biological half-life. So this refers to the time required for the patient to eliminate half of a substance through normal processes such as urine, feces, exhalation, perspiration, and the like. So by the way, class, we have been mentioning about radiation therapy and nuclear medicine. So radiation can also be injected or ingested by the patient, believe it or not. Yes, pwede siya ma-inject, pwede tumaron sa pasyente. So, radiation yan, meaning the radiation is inside the body of the patient. So, paano niya ito ma-excrete or ma-eliminate, ialawas? So, this is through processes such as urine, feces, and the like. So, may kita tinatawag liwat nga biological half-life. Again, this is the time required para ma-eliminate ito niya nga radioactive substance. So, there's a span of time. Oo. So, ganun talaga siya. Sugad pa man natin dati, predictable itong radioactivity. So, yun. Halimbawa, ma-injecta iya itong radiopharmaceutical. Tawag kasi ito, radiopharmaceutical. Ma-inject siya sa kanya, di man ito pwede nga adtula sa lawas at pasyente. Siyempre, i-eliminate ito. So, by urine, by tae, di ba? Exhalation, perspiration, and the like. So, that span of time nga ma-eliminate is what we call the biological half-life. The third type of half-life is the effective half-life. So, it is the combination of the physical and biologic half-lives. So, it refers to the time required for the patient to eliminate half of the radioactive compound through the process of physical decay and biologic elimination. So, effective is physical plus biological half-life. Okay, so taron ta ha, the three types of half-lives. So first, we have physical half-life, in which we said this is our topic for today. And then we have biological half-life. That is the time that the patient will eliminate the substance through normal processes. And then we have effective half-life. This is physical plus biologic half-lives. Okay, so for us to predict the radioactivity for a specific time frame, so there is what we call the radioactive decay law. So this is the rate of radioactive decay and the quantity of material present at any given time that is described mathematically by a formula known as radioactive decay law. But by the way, class, we won't go farther with this formula because this is quite applicable to radiation physicists, not for radiologic technologists. We will entertain a different approach. Later, we will discuss that. So, from this formula, we obtain a quantity known as half-life. Ayun. So, the symbol is T1 half. Half-lives of radioisotopes vary from less than second to pwede siya years, di ba? Napansin natin kanina, technetium, that is in 6 hours. Radium, that is in 1,600 years. So, each radioisotope has unique characteristic half-life. Okay, so again, radioactive decay law. So, this is the mathematic formula for us to determine the rate of radioactive decay and the quantity of material present at any given time. So, we have the formula A equals A naught E raised to the negative lambda quantity time. Ayun. So, A represents the remaining activity after it has elapsed. A naught, A subscript 0, this is the initial activity. E, this is the natural number or the half-life value of a radioisotope. So, we have examples like radium, 1,600 years, cobalt, 5.3 years. Okay. So, negative lambda, this is the decay constant. Constant has, so it has a value of 0.693 per half-life. And we have T, or the time it has elapsed. The time interval. Okay? So, again, I won't go deeper with radioactive decay law because this is quite for radiation physicists. So, we are radiologic technologists, we might entertain a different approach. So, adit aton pwede adit aton mas madali, especially for you, BSRT students. Okay, so maghimo kitang table. Okay, so in the first column, okay, so we have half-life. So, the sequence of half-life. First half-life, second, third, fourth. So, kung masipag ka, pwede ito up to 100. Up to 500 if you like. Kung maigoy mo papel. So, second, we have the activity. So, do not be confused ha. Do not put the original activity. Like, mabasa ni mo ha problem, masugad nga itong the activity was measured to have 1,000 millicurie at 6 a.m. So, the 1,000 millicurie is not the activity at half-life 1. That is the original activity. Otherwise, pag ibutang mo dida si 1,000 millicurie, sala ito tanan nga imo table. Oo, kasi gimbutang mo dida actual, in which sa atong table, first half-life dapat. Tapos, masugad nga to, the half-life of the material is 4 hours. So, ayo, kadi kita ha, third row. Okay. So, do not put the initial time. Ayaw dia ibutang ang 6 a.m. So, meaning, mag-react kahin 4 hours from 6 hours. 6 a.m. So, 7, 8, 9, 10. So, meaning, the first half-life will occur at 10 a.m. So, 10 a.m. imo igbutang nga da. Diri kay an initial time. Nakuha? Sige. Pakiana? Of course, dahil yung mapakiana akong dayon. Sige. We have different platforms sa take note. Pwede natin ito i-grace na aton questions. Next, we have fraction remaining. Hini nga row. So, ano't pwede natin himon dida? Of course, from 1 whole, naging 1/2. So, 1/2, i-divide mo na naman siya by 2, 1/4. Divide again by 2, 1/8. So we have the formula, 1 over 2 raised to n. So 1 over 2, so since sa first half-life, waray pa man natin multiplier, so 1 over 2 pa lang siya. Pero pagka din na didiha second half-life, pwede na natin ibutang 1 over 2 or 1/2 raised to 2, so that will become 1/4. So, ang importante kasi ay halimbawa sa mga board examinations, mabutang adto nga, what will be the fraction remaining at the 50th half-life? So, alang ka man dida compute pa. Diba? Alang ka man maghimon table nga halaba-laba up to 50. So, ma-consume kain time sa imo exam. So, pwede mo gamiton ini nga formula. Hahanap mo man ito na iya fraction. Diba? Using especially mga scientific calculator. 1 over 2 raised to 50. Okay? Sige. Okay, so for now, pwede natin magsugad nga 1/2, 1/4, and next ito, 1/4 divided by 2, 1/8. Next ito is 1/16. Again, kung masipag ka, up to 100, mas ikaw, depende lang mo. So, 1 half or 1 divided by 2 times 100, amo ito imo percentage. So, first natin nga half-life, so from the original, 1 over 1 whole, so naging 1/2 naman la siya. 1 over 2 or 1 divided by 2, that is 0.5 times 100, that is 50%. So divide mo by 2 and 50%, 25%, so on so forth. So ganun aton. So may imod mo nga for the entire nga mga problem solving, masusugad mo nga same lait aton fraction remaining and percentage remaining. So 1 ma-start siya sa 1/2, next 1/4, 1/8, 1/16, 50%, 25, 12.5, and 6.25%. So nakukuha. Yan, very good. So I want you to get a piece of paper, of course, a ball pen, para mag-try kita pag-answer. So for now, ako lang no? Mamatilaan ay kamo akon. Tapos kita niyo paano pag-answer. Tapos niyan, I will give you time. Di ba? Para maka-answer liwat kamo at aton activity. Sige. So in 5, 4, 3, 2, 1. Okay, so I know may dana ka mo ball pen ngahin papel. Sige, let's try this problem. So a certain radioactive material started with 4,242 CPM or cycles per minute at 6 a.m. So the half-life of the material is 4 hours. So letter A, what is the remaining activity at 2 p.m.? Letter B, what will be the activity after 4 half-lives? Now, letter C, what percentage of the initial activity will remain after 24 hours? Letter D, what fraction of the initial activity will remain at 6 p.m.? And letter E, how much activity was lost at 10 p.m.? Sige, ano taton answer? Letter A? Letter B? Okay. So, what I'm trying to say here is, makoreano kasi for you, parang first time pala niyo makita mga sugad hini nga problem. So, ako lang tagi lang ako yung chance nga mag-answer. Tapos, kita lang ayaw lang pagsurat. Later na pagsurat kasi para mas mabaro niyo. Kasi kung sige ka mo pamati, tapos, sige yung surat, so mawarat focus. Pamati lang tapos surat na later. Sige. So, our initial activity is 4,242 CPM. Again, do not write that on the first column or first box. Dito activity Kasi initial siya. And meaning, nato nagsusurat is the activity at the first half-life. And do not write 6 a.m. at the first box dito time. Kasi otherwise, mali tanan imo table. So, given na didea, then yung half-life is 4 hours. Sige, are you ready? Okay, sige. Aditak table. Yan. So, 2,000, given naton 2,442 CPM at 6 a.m. So, 2,400, nalipat na ako. 4,242 CPM divided by 2. So our activity at the first half-life will be 2,121 CPM. Yan. So, what is the initial time? So, 6 a.m. So, maihap kitahin 4 hours. So, 7, 8, 9, 10. So, meaning, ma-occur ang first half-life at 10 a.m. With, of course, our fraction should be 1/2. Tapos, the percentage remaining is 50%. Kuha. So, una pala ito, ano? So, sige, divide natin. 2,121 CPM, divide again by 2. So, that will give you 1,060.5 CPM. Okay? So, from 10 a.m., count ka another 4 hours. So, 10, 11, 12, 1. So, that will be 2 p.m. Plus that, another, nga nako-confuse tak mga estudyante danay, na lilipat herat AM ngayon PM. AM aga, PM hapon. Kung malipat pa ba. So, 1/2 divide again by 2, that will become 1/4. And 50% divide again by 2, that will be 25%. Nakukuha? Sige. Third half-life, the activity is, so 1,060.5 divide again by 2, so that will give you 530.25 CPM. So, from 2 p.m., count ka another 4 hours. So, 3, 4, 5, 6 p.m. na. And then, 1/4, divide again by 2. So, that will give you 1/8. And 25%, divide again by 2. That will give you 12.5%. So, the activity at fourth half-life. So, 530.25 divide by 2. So, that will give you 265.125 CPM. And, ihap ka from 6 p.m., ihap ka in another 4 hours. So, that's 7, 8, 9. So, that will be 10 p.m. So, the next, fraction remaining. So, 1/8 divide by 2. That will be 1/16. And then, sa percentage remaining, 12.5 divided by 2. So, that will give you 6.25%. Next, activity at the fifth half-life. So, 265.2 divided by 2. So, that will give you 132.56 CPM. And then, from 10 p.m., count ka na naman another 4 hours. So, 11, 12, 1, 2 a.m. So, 1/16 divided by 2. So, that will be 1/32. 6.25 divided by 2, 3.125. So, that next, we have the sixth half-life. The activity is 132.56 divided by 2. So, that will give you 66.28 CPM. So, count ka another 4 hours from 2 a.m. So, that will give you 6 a.m. So, gin-end ko na din kasi ang aton problem is only up to 24 hours lang naman. Nag-start siya at 6 a.m. Of course, para maging 24 hours, mag-e-end liwat siya 6 a.m. the following day. So, next, fraction remaining, 1/32 divided by 2. So, that will be 1/64. And then, 3.125 divided again by 2. So, that will give you 1.56%. Sige, kopyahalangon tapos kung may pakiana, again, you may reach me in different platforms. Do not hesitate. Okay, sige. Now, we can answer our problem. Okay, so, ade. So, again, the question was, a certain radioactive material started with 4,242 CPM or cycles per minute at 6 a.m. The half-life of the material is 4 hours. So, letter A, what is the remaining activity at 2 p.m.? So, mahanap mo na siya didi. 2 p.m. So, ano natin activity at 2 p.m.? Adi siya. So, that is 1,060.5 CPM. Okay, correct. Next, what will be the activity after 4 half-lives? So, as you can see in here, this is fourth half-life. So, an activity is 265.125 CPM. Okay. Next, what percentage of the initial activity will remain after 24 hours? So, nag-start siya, di ba? 6 a.m. So, normally, mag-e-end siya or para maging 24 hours, kailangan adi siya sa 6 a.m. Ang pakiaan na what percentage of the initial activity will remain after 24 hours. So, adin aton percentage. So, that is 1.56%. Okay? Next, what fraction of the initial activity will remain at 6 p.m.? So, hanapon mo, adi 6 p.m. So, ang pakiana, fraction. So, at 6 p.m., adi, ang iya fraction is 1/8. And, how much activity was lost at 10 p.m.? So, hanapon mo 10 p.m. Ayun. Ang kanya activity is 265.125. Our question is how much activity was lost? Peraan nawara. So we have to subtract 4,242 CPM minus 265.125 CPM. Pera, sige. 4,242 CPM minus 265.125 CPM. So, pera, there you have it. So, 3,976.875 cycles per minute. So, may pakiana. Sige, kopyahan mga answers. Then, kuha again, kung naada iyo ada pa ang papel, ngayon ballpen. So, mag-a-answer kita yan na. So, here is our problem. So, a radioactive material was measured to have an activity of 2,848 millicurie at 10 a.m. So, at 4 p.m., the activity was reduced to 712 millicurie. Letter A, what is the half-life of the material? Letter B, what is the activity of the material after 12 hours? Letter C, what fraction of the initial activity will remain at 7 p.m.? Letter D, what percentage of the initial activity will remain after 12 hours? And letter E, how much activity was lost at 10 p.m.? So, tatagan ko kamo in 5 minutes para mag-answer hini nga problem. And your time starts now. Okay, time is up. Okay, so, sige, balik kita. Okay, so our problem again is a radioactive material was measured to have an activity of 2,848 millicurie at 10 a.m. So at 4 p.m., the activity was reduced to 712 millicurie. So dito kasi hindi siya nagbigay ng exact half-life value. So which means we are going to find out pa kasi letter A nga, what is the half-life of the material. So paano nyo kaya nahanap yung half-life? So, sige. What is the activity of the material at 12 hours? So, sige, our initial activity again is 2,848 millicurie. So, our initial time is 10 a.m. So, kailangan diri ini makikita ha table. Ito, pwede ito makita 4 p.m. So, tigamnan naton 2,848. So, ano't una niyong nakasurat di daha iyo activity, first half-life ano't iya activity. So, titigam ta kung hain 712 tapos nag-start siya 10 a.m. tapos 4 p.m. Sige. So, 2,848 divided by 2, that will be 1,424 millicurie. So, tapuson ko lang una sa activity ha kasi diri pa naton aram kasi kung ano an half-life. So, diri ko pa magi-gauge ang time. So, i-divide naton ngun si 1,424 millicurie divide again by 2. So, that will give you 712. Diba ito ini sa problem? So, meaning, ada siya sa 4 p.m. Okay, so 712 millicurie tapos ada siya sa 4 p.m. So meaning duha ka half-life na an nag-elapse. So balikon ta ang problem. So para mahanap naton si half-life. Okay. So half-life is so the number of hours elapsed pira ang time interval from 10 a.m. to 4 p.m. Tapos, pira na ang number of half-life. So, aton problem kanina, nakita naton nga pan-second half-life. Yeah. So, ihapon naton from 10 a.m. going to 4 p.m. 11 a.m., 12 noon, 1 p.m., 2 p.m., 3 p.m., 4 p.m. So, 6 hours ang naglabay ang iya interval. Pero ang iya number of half-life, duha. So, 6 divided by 2 meaning we can say that letter A, 3 hours it aton half-life. Sige, we will check later. Tigam ni naton ha. Sige, balik kita table. So, activity at first half-life is 1,424 millicurie. Tapos, sa second half-life is 712 millicurie. Amon aton given. Tapos, 712 divide again by 2. So, that will be 356 millicurie. Sunod, 178 millicurie. Okay, 89. So, divide again by 2, 44.5 millicurie, 22.25 millicurie, and then 11.125 millicurie. So we said that iti half-life is 3 hours. So from 10 a.m. count ka 3 hours, 10, 11, 12. So that will be 1 p.m. Iti first half-life. So given naton ang 712 ato siya sa 4 p.m. Tama. So tama. 3 hours it aton half-life. So, sunod sa 4 p.m., count ka another 3 hours. So, that is 7 p.m. Then, 10 p.m. Then, 1 a.m. 4 a.m. 7 a.m. Tapos, 10 a.m. para makomplete naton ang 24 hours nga adtot aton problem. Okay? So, since masayo naman ladi diha fraction so 1 half, 1/4, then 1/8, 1/16, 1/32, so on so forth. Same as through the percentage. Master kita 50%, followed by 25%, 12.5%, so on so forth. Ayon. So, very good. Ang galing ng mga BSRT2 students. Palakpakan nyo na. Okay, so let us answer the problem. Syempre, alangan ba naman din na matapos ang aton problem? Syempre, kailangan naton answeran ang problem. Sige, so add-in problem, a radioactive material was measured to have an activity of 2,848 millicurie at 10 a.m. So at 4 p.m., the activity was reduced to 712. So letter A, what is the half-life of the material? So we said this is 3 hours. If you get the correct answer, then very good. Next, what is the activity of the material after 12 hours? So mag-ihap kita from 10 a.m. pakhin 12 hours. So 10, 11, 12, 1, 2, 3, 4, 5, 6, 7. So that will be, ano nga time? Para makakomplete ya, that will be 10 p.m. gihapon, di ba? 10 a.m. to 10 p.m. para maging 12 hours. So our answer is 178 millicurie. Very good. Next, what fraction of the initial activity will remain at 7 p.m.? So 7 p.m. ade. So anong fraction? So that is 1/8. Next, what percentage of the initial activity will remain after 12 hours? So nakuha natin kung hainan ka 12 hours sa 10 p.m. And pakiaan na nga di percentage at 12 hours. So 6.25%. Then how much activity was lost at 10 p.m.? So ang aton activity is remaining is 178 millicurie. So meaning 2,848 millicurie minus 178 millicurie. So that is 2,670 millicurie. Ang galing ng mga estudyante ko. So okay, so that ends my topic for this morning. So if you have questions, alam nyo na, hindi ko na ulitin kasi how many times ko na sinabi. Okay? So, paki-check sa Moodle. So, there are mga activity questions that will be graded. So, just PM me your answers. Or, no. You can, and mga cannot access sa Moodle, you can PM your answers, and those who can access sa Moodle, so you can answer directly sa Moodle. So, thank you so much for watching, and I hope you have learned something from this video. So, ingat kayo palagi, and then, goodbye!